Good evening, viewers, and welcome to the Wells Fargo Day 4 of Shaastra 2021. Over the past 3 days, Shaastra Spotlight has brought to you an amazing lineup that has consisted of exciting fireside chats, insightful lectures, and interesting demonstrations. For the concluding fireside chat in the Spotlight Lecture Series and in association with UpSkill, we are honored to have with us today Dr. Viral Shah. Dr. Viral Shah is a co-creator of the Julia programming language and is currently the CEO of Julia Computing. He has also been an integral part of the Aadhaar project by the UIDAI. From his experiences of working on Aadhaar and other technological projects with the Government of India, he has co-authored the book Rebooting India with Nandan Nilekani, where a roadmap for a technological enabled social transformation of India is drawn. We welcome you, sir.
Thanks, Tushar, for that introduction, and I'm happy to be on this, on Shastra's uh, upskill program.
Yes, we shall now proceed with our fireside chat. Our first question is, could you give us an insight into your motivation behind creating a new programming language and what shaped Julia as we know it today?
Yeah, it's like they always call it, right? That necessity is the mother of invention, and this is why we started the Julia project, right? We had no idea what it's going to become, and if anybody except for the four of us who started it would be interested. So I have three other co-creators, Jeff Bezanson, Stefan Karpinski, and Professor Alan Edelman from the MIT Math and Computer Science AI Laboratory, math department there. And all of us have been wanting something that is, we call this the solving the two language problem, right? So we were all very familiar with writing our algorithms in Python, R, MATLAB. Back then it used to be more MATLAB, but increasingly Python and R now. But these are the languages in which these are dynamic programming languages which are much easier to use, closer to your math, and easy for an engineer, for a scientist, for a quantitative analyst, an actuary, a pharmacometrician, anyone who's doing applied mathematics, for them to work with. Those are the right kinds of languages. But then you have C, C++, Java for writing high performance deployment centric code. And we wanted something that had both. So the ease of Python and the speed of C. It was believed back then that it was not possible. So you would always, even in my own PhD, you sort of wrote all your high level code in one of the dynamic languages, and then you rewrote it in C++ or Fortran also for performance. And we just thought that the world didn't have to be that way. You didn't have to write every program twice. And that's how we started out the first line of code in 2009.
That was an inspiring answer, sir. So, following up, the article that you wrote introducing the world to Julia went viral on the web. Did you expect it to make such a splash initially? And could you tell us more about that experience?
About rebooting India, right?
About the article which you wrote introducing Julia to the world when you launched Julia.
Sorry. It's a bit too early for me. So, yeah. So that's right. So we spoke about this was in February, I think 2012, where we talked about why we created Julia. And what happened was, so just like most open source projects, you get started, you sort of put it back then. GitHub was still new, and we put it on the internet, and almost no one sort of found it, right? I mean, that's the biggest problem that you have, when even back then, right? Like, why would someone be interested in this project and come on and try it out, and then maybe even decide if they like it and if they want to contribute to it and use it? We had not even released a version 0.1 back then. And it was in February 2012 that we actually started, that we put out this blog post called Why We Created Julia. That's the first blog on the Julia blog. If you Google those terms, you'll find it. And we sort of outlined this. It turned out to be some sort of a manifesto, right, where we said that we want the ease of Python, the speed of C, the scalability, the performance. We wanted to be as easy as Perl for string processing, and so on. And so, like, we wanted the best of all the languages in terms of performance and scalability. And what happened was we posted it on Reddit and Hacker News that day. And obviously, we didn't think anything was going to come out of it. Actually, the blog post was not even supposed to be ready. It was accidentally posted by me, thinking that it was ready because all of us were in different time zones. And, Stefan had sort of penned this blog post originally. There were a couple of comments that had started showing up. So I thought, hey, we are live with this. But it turned out that it was just a couple of his friends who I did not know about. And one thing led to another. I posted it on Reddit. I think someone else posted it to Hacker News. And it was just, all of us were not prepared for it, but it just went viral overnight. And that's sort of how the whole thing got started. So we had over 100 contributors that contributed to Julia in 2012, right? Just from that one blog post going out over the internet. And every year, I think we added 100 contributors to Julia. So today there's over 1,000 contributors. And I think this is a bit unheard of, right? So very few projects, like you have Linux, or you have sort of Mozilla, or all these kinds of major projects that have these many contributors. Especially programming languages tend to be harder. It's harder for getting contributions. It's hard for people to sort of make a contribution because modifying the core of a language has such a huge impact, and it's not easy to get into. But I think what we did right was that we had a lot of Julia written in Julia itself. So if you wanted to get performance, obviously you have to just write Julia code. And so that made it easy for a lot more people to get plugged in. And what was really amazing was that there was sort of this group of people who really saw the potential in Julia right away from day one. And they said, this is very rough. It barely builds. There is no released version, but I can see where this will be. Like, you could already run it 10 to 100 times faster than Python, even like back then, or MATLAB or R. And so a lot of people got excited. They started contributing. We put out a version 0.1 around that time frame. And then we've been sort of releasing, new versions at a very steady pace from there on. So I think it was really that one first blog post that sort of got everything off the ground. So today we are at what I believe is to be over 1 million Julia users worldwide. They're all technical users. They're all some of the smartest people in their respective universities or companies, who are using Julia, because the people who work with Julia need high performance. Existing tools do not work, and they're pushing the boundaries, right? So 1 million Julia users is what I think we have in the community, and we have over 5,000 Julia packages that have been contributed in the meanwhile. Not to mention sort of the ability to call any other language from Julia, whether it's Python or C, Fortran. So it's really it's really that first blog post that got it going.
Wow, that is a very informative answer. So the reaction to Julia was much better than expected, as you said. So by when do you think Julia would grow on to replace languages like Python entirely and also make an impact outside the scientific realm?
That's a very good question. So I think it's so often languages, people often think, right, that you have a new language, so you're going to replace an old language. And it's natural to think in those terms, because after all, how many programming languages will a person learn, right? So you might learn and get proficient in maybe 3 to 5 languages over a lifetime, right? Like, that's about the number that I think I'm at. I think that's what many people are at, right? I mean, you may be aware of more or know more, but meaningfully, you probably will use only a very small number over your career. Um, and so it's not a zero sum game, actually, right? So it's not that I will suddenly, I like, even I have a old Python code that I still have, and personally I have migrated all of it to Julia by now. But I don't think it's realistic for most people to do that. So you will always sort of have this, all these different things existing at the same time. And it's great to have that choice and that variety and those diversity of ideas. And that have a great community of users in Python. Machine learning, the machine learning community has especially adopted it in a much bigger way, thanks to TensorFlow and PyTorch. Julia has a lot of interesting machine learning stuff, but with a different take, focused on scientific machine learning. But the total community, the sum of the parts, the whole is greater than the sum of the parts here, right? And so in applied mathematics, in any form of mathematical programming, I think there is no doubt that Julia will sort of at least be a strong a contender, if not, in the first position. I like to think that, we will be the language of choice for everyone very soon, and we already are for many people. But all these other tools will continue to exist. There will be amazing software, and they'll be, you can call them from each other. And so increasingly what happens is that because of Julia's performance, people write libraries in Julia now, and then Python and R users want to leverage those. So things are now going the other way. That when you were a young language, Julia had to call Python and R, but now people are increasingly calling Julia from Python and R. And even C++, we have customers who embed Julia into C++. In terms of being a more general language, there is nothing inherently in Julia that makes it specific to only one domain. We actually have people doing a lot of interesting things in Julia outside of mathematical computing. So there is the whole HTTP stack that Jacob Quinn has written, which allows you to write web services in Julia and serve serve microservices architectures kind of stuff. You can so for one of the very first examples of this was Sudoku as a service that somebody wrote, where if you give Julia a Sudoku problem, you could send it over a website, and then it would use an optimization problem to solve the Sudoku using the Julia jump package, and then present the answer back to you over the website. So that was a very early thing that someone called by the name of Ian Dunning did back in the day, but that has come a long way. People are writing databases in Julia today, experimenting with new ideas, analytical databases especially. Um, and there are just so many other applications. So I already talked about web serving, right? Because of Julia's performance, you can write a very high performance web server in Julia, and people have done that. One of my favorite non-technical projects is this project called Franklin, which is a static website generator in Julia. So if you're a Julia user especially, it makes it very easy to create beautiful websites. And then if you look at all of Julia's documentation, all of that infrastructure is completely done in Julia itself. So our community is mathematically oriented, is oriented towards technical computing, but people are actually doing a lot more things. And I think we have some ways to go, and I'll talk a little bit more about that. But it is already happening.
Yes. So talking about a few applications of Julia. Julia was selected by Caltech's Climate Modeling Alliance as the implementation language for generating a global climate model and studying the effects of climate change. What features of Julia make it suitable for such a purpose? And could you tell us a bit more about how the research has been going?
Yeah, that's a very good question. So the Climate Machine team at Caltech, it's spread out across Caltech and MIT, and they chose Julia as their language of implementation because, finally, as a scientist, you need to decide if you want to focus on the science or you want to spend your time programming, right? In many areas like climate science, they're very simulation heavy. So you have an understanding of the world around you in the form of mathematics, and you have data sets, right? So I have data from climate patterns, from weather patterns, and I satellite data, data coming from sensors, all sorts of things, and I need to synthesize it. I need to build my models, and then I need to have a view on the future, right? So modeling is about creating a model of the world, of the climate as we understand it. Simulation is about simulating it forward and predicting what might happen to climate. Is Chennai going to get too much rain in some years and no rain in some years? Is Bombay going to see a sea level increase? Is Calcutta going to see flooding, whatever it is, right? I mean, or like Kerala, right, where we had all these massive floods. So climate change is here, right? And the question is, how do you use simulation, how do you use modeling and simulation to sort of get a better understanding of it, and then make informed decisions that are outside of the scientific space, right? Policy decisions, safeguarding our population, safeguarding our agriculture, and so on and so forth. So the climate team actually chose Julia so that they could focus on the science and spend lesser time writing code. One of the things that the climate people really sort of need is the ability to run on GPUs. So if you're doing machine learning, you always know that GPUs give you all this performance, and they take much lesser power. So I can have a data center full of GPUs and still get supercomputer level performance compared to using CPUs, for example, for certain kinds of linear algebra or computations. And this was the case in climate science as well, in climate machines. So they are combining machine learning with climate modeling. They want to heavily use GPUs because they want to get the fastest possible performance out of their codes. Julia is one of the very few languages, maybe the only language after C++ that has native GPU code generation. In fact, it started out as the PhD thesis of Tim Bassard, who is one of my colleagues at Julia Computing now. From he did his PhD at Ghent University in Belgium, and he wrote along with Valentin Shuraev, who's at MIT, the first Julia GPU compiler. And the climate machine people came along a couple of years later, and they said, "Wow, this is fantastic! This is exactly what we need. That we can write in Julia, very simple code. It's almost like the mathematics. Press a button and run it on GPUs. That's fantastic." And so this is how all of this partnership came along. The Climate Machine team also has many of Julia's core contributors. I mean, the team is over 50 people now who are working with Julia in some sense, if you go to their website. And it's one of the most audacious climate simulation projects today. And they're not using Fortran. They're sort of pushing the boundary and writing new, brand new climate codes that are, cutting edge modern science and machine learning.
Thank you for that insightful answer, sir. So as we move forward, how do you think Julia will evolve, and what fields do you think it will make an impact in? And in your opinion, what will be the role of industry and academia in this transformation?
Yeah, so Julia how will it evolve is always a very good question, right? Because people don't like their languages evolving too much. But then if you're not keeping pace with change, you're also sort of not enabling the new kinds of applications that are coming along, right? So we announced Julia 1.0 in our JuliaCon at London. That was our fourth JuliaCon, I think, back then. And in 2018, we said, okay, the language has been frozen. So the way we do it is we follow the semantic versioning model, which means that once you go version 1.0, any forward breaking changes are, any backward breaking changes. Forward is okay. You can add new features without changing the version number, but we cannot change any code. We cannot break backwards compatibilities. If someone wrote a code after 2018 using Julia 1.0 or higher, it will be sort of compatible and not break until Julia releases version 2.0 and going forward. And we decided that we're going to hold this for a very long time at 1.0 compatibility. That said, there will be evolution. So we have added significant new features to Julia since then without breaking backward compatibility. We upgraded our package manager to make it really easy for people to work with. And we have an amazing workflow for people contributing new packages. So for example, that's what led to the creation of 5,000 packages. We added binary builder, which allows all existing C and Fortran libraries to be easily installed by Julia users without having to compile them on any operating system, Windows, Mac, Linux. And we run this entire package and binary distribution infrastructure to make it easy for Julia users. We operate lots of cloud services and all that stuff in order to, again, make it easy for everyone. One of the other things that is major features of, I spoke about GPUs, for example. So that was a major one that came recently. We had an early port to Google's TPUs that has been harder to carry on because it's not a really large community in some sense. So the TPU port is dependent on Google's support, but it exists. There's a proof of concept. So you could run Julia on Google's tensor processing units. One of the really valuable contributions or additions that came to Julia has been multi-threading, actually. So there is no dynamic high performance. There's no. So R, Python, MATLAB, none of them have user-facing multi-threading today, for example. But Julia has user-facing multi-threading, and it is probably one of the very few languages that has composable multi-threading. So you can spawn thousands, millions of threads, and they'll all coexist. And that was a completely new capability that we added in Julia 1.3. And then there have just been tremendous improvements to Julia's compilation model and on all sorts of sort of nooks and crannies of the language um, that are very exciting. There are too numerous for me to talk about, but I would say look at our we publish a news and a highlights with every release, and I would suggest anybody who's is interested to go to the Julia website, join the community, look at our releases.
Thank you, sir, for telling us about Julia. It's very interesting.
Oh, I
So,
should, sorry to interrupt you. You did ask another question which I didn't address, which is
yes,
how
sir.
will industry and academia help?
Yes, sir.
And I actually have some very interesting things to share there. So Julia is a product of academia, and it was anchored. It has its roots in MIT, um, but it is also heavily being used in industry, especially after Julia 1.0. And one of the things that happened is one of our collaborators, Jared Revels from who started a company called Beacon Biosignals, gathered a consortium of companies to take a lot of the code that they've developed inside those companies in Julia and open source it. So several companies, so Julia Computing, for example, already, we open source everything on an ongoing basis. So we were not participants in this hackathon because we didn't have anything inside the company that we needed to open source. But what Jared did was he gathered a lot of companies and people came together. I think from Beacon Biosignals, we had people from Invenia, we had people from maybe Relational AI, and a few other companies. These are from Puma's AI. These are all startups that are using Julia as the core platform, and there are many other companies doing that. But these few companies actually are very many core contributors to Julia work, and they all came together and open sourced a bunch of packages, and they published a blog post. So increasingly, I would say that it's a very diverse community of users that is actually pushing things forward. One of the things that we've done is that we have made it easy for people to extend Julia without having to modify Julia itself. And this is a core principle within the system of multiple dispatch. That is the basis of what Julia is. So it's not an object-oriented language, it's a multiple dispatch language. And one of the things multiple dispatch does is give you this capability to externally extend your programs, where someone can take your program, extend it without modifying it, and add significant new behavior. And that has led to all of these things being possible in a very broad sense.
Yes, sir. So the possibilities with Julia seem endless. You've also worked closely with Nandan Nilekani and with the Indian government for implementing the Aadhaar project. So can you explain in a nutshell what your role in that was, and how was your experience there? And could you also tell us about the challenges you faced and how you overcame them?
Yeah, so it was an amazing experience to work on Aadhaar. It was not something you can plan for. It was sort of a random occurrence in some sense. I did not actually know about Nandan Nilekani when I first met him, and I was giving a conference talk back then in Delhi. I ran into him, and we just exchanged some notes, and I just decided at that point I was I had this opportunity to maybe the company that I worked for actually had got acquired by Microsoft, and I had the opportunity to maybe join Microsoft or go back to MIT as a postdoc or work on Aadhaar. And I said this sounds like the more interesting option, and I decided to just on the spot stay back in India and work on Aadhaar. It was a very interesting journey. Actually, I've detailed it very, very deeply in our book, Rebooting India. And I think more than sort of being a roadmap for the Aadhaar project and what technology can do in India, um, it is also an example of how someone from outside of government can join government in India, what challenges they may face. And there are many, especially those of us who come from the private sector and who have not interacted much with government before, do not understand how the government works, why the government works in the way it does, and what are the incentives of government officers, how, why do they behave in a certain way. And it might look foreign to you. You might think that these people do not sort of understand things. They sort of they're stuck in their old ways, from 30 years or maybe even 100 years ago. But once you actually start working within the system, you realize why it works the way it does. You realize its strengths and its weaknesses, and then you sort of start working towards all those within that understanding. If once you have, it's just like any other team, right? Once you understand why your colleagues operate the way they do, once you understand that you have the same shared vision as them, but they're bringing a different perspective, it's so much easier to work on a common goal. And we had the goal of enrolling 1 billion people into Aadhaar. It was no small goal. We enrolled people into Aadhaar faster than people signed up for WhatsApp, for example. So that is the achievement of the Aadhaar project. And it was one of the most fulfilling things that I ever did. One of apart from Aadhaar, we discussed many other projects in Rebooting India around subsidies, around payments, UPI, toll collection, so many different things. All of those projects, without even our involvement, have been successful in the government of India, right? They're live, they're running. Like, everyone drives through a toll, electronic toll booths today. Everyone pays their GST, which has reshaped the Indian manufacturing economy. You have all these amazing things that have happened. Of course, UPI for payment. So once you get a few things right and you set up the right culture and you set up the right tone, I mean, the government is just fantastic at taking new ideas and running with them if it's convinced at the top, right, by your elected officials. And that's what happened in Aadhaar. That's what happened in all these projects after Aadhaar. But it was not easy to work. What Nandan really enabled was bringing a startup mentality, a startup ethos, a startup energy within a government. So it was, he commonly referred to it as a startup within government. And we were marrying sort of the energy of a startup with the scale of government and doing something that was never done before at that pace, right? You often hear about so many projects in other countries which spend, I would say, 100 times more money and get probably very little outcome. But this was different, and I think we should all, as a country, be proud of what was achieved. And I think with this pandemic, it has been fantastic that it had all that infrastructure had been set up, because you could roll out your subsidy payments, you could roll out your direct benefit transfers. People had money in their accounts, they could buy food, they could all these things that you needed actually were, thankfully, Aadhaar was in place by then. But it was not an easy experience to jump into the government and work. And I now that I look back upon it, I would think that the government officials almost had an unwritten rule of trial by fire, that you know that they would just had such a hard system to accept people to join, that most people who are not committed would just leave within the first few days or months. So it really took a lot of grit and staying power to be there. And I was very lucky to work with two of my colleagues, Ashok Pal Singh and Rajesh Bansal. Ashok Pal Singh came from the Department of Posts, actually, and Rajesh Bansal from the Reserve Bank of India. And the three of us were tasked with the job of figuring out Aadhaar in payments. So the whole micro ATM infrastructure, linking up Aadhaar, making Aadhaar a payment service, right? A payment instrument, basically, right? So can I receive money with an Aadhaar? Can I send money with an Aadhaar? And all of that has been live today. The government using your Aadhaar can send money into your account. You can put your fingerprint on a micro ATM and withdraw that money from the bank in an interoperable way. And it took a lot of time and effort. We went around from government department to government department, begging them to use Aadhaar, begging them to enable the use of Aadhaar, convincing them that electronic transactions are actually legally acceptable, using encryption and digital signatures in the IT Act to replace paper with electronic documents, and convincing the anti-money laundering teams that this is not unsafe and it's in fact stronger security than existing systems. So we had to do a lot of things in the ecosystem, one by one, changing one line of law here, one regulation there, across departments. And we did it all in 2012 and 13, I would think. And it's hard to convince someone of an application when the main product doesn't exist. So Aadhaar was just rolling out. But because I think of the work done by our team, and we talk about all of this in Rebooting India, that it was actually possible to get all of this out there.
Thank you, sir, for that insightful answer. So, in the book Rebooting India, you've spoken about how the next wave of developments in India must be implemented in a manner that deploys technology at a much deeper level. So, could you tell us about the rationale behind this suggestion? And do you think India has risen up to the challenge?
I think uh, I think I think India is capable of doing many things once we put our minds to it. And I will focus maybe a little bit more on the government domain at the moment, because I think the private sector always has its incentives, right? So to do what it needs to do. And there is, the way so in the private sector, the way our telecom companies have rolled out the infrastructure. I mean, today, the cost of data in India is 1/100th of what I would pay in the US, for example. And, every person in the country has maybe not even one but two mobile data connections, right? And entertainment, music, videos, everything is online, right? That you can imagine in a way that is on par with anywhere else in the world. Or if you think about e-commerce, if you think about logistics, about all these things, I would say that we are on par. But let's think about government for the moment, right? And one of the things we talk about in our book is what's the role of government, right? And one of the quotes that I like is that the role of government is not to do things better or worse than the private sector is doing or anyone else is doing, but it is to do things that nobody is doing at all. And if we go back, right, I think some of the best achievements of the government of our country have been scientific in nature. And I personally believe that science is a way to address every possible challenge, whether it's climate, whether it's a pandemic, right? We need to develop a vaccine for climate. We need to understand what's causing it. We need to, maybe sequester all the carbon dioxide and put it back into the ground where the oil was removed. We need to reduce the CO2 emissions from the way cement and concrete are manufactured. We need to do so many things in our agriculture, right? So there is the whole expectation of how the climate is changing, and then what we need to do to address that change, and that upheaval that will be caused in society. How do we address it, right? And this is very much in the government domain, for example. So we have risen to these challenges in the past, right? So, for example, one of my favorite, I'll share with you first three of my favorite scientific examples from India. One was, of course, Dr. Homi Bhabha, and what was achieved with the Indian Atomic Energy Program. It was created with the intention of dual use, security as well as power security as well as energy security, um, and national security. Sorry, national security and energy security. And India caught up with some of the world's best back then in a completely indigenous way with a sharp focus. And this went back to the Nehru government days. We then figured out our space program, right, with ISRO. And I think you have a speaker, at Shaastra who's talking about ISRO, one of the earlier chairpersons.
Yes.
So that was an amazing thing that we put our minds that space is a frontier, that if you can put a satellite in space, you can do health, you can do education, you can do information to farmers, you can do so many applications. And if you think about the mission with which that was set up, I mean, it was just fantastic, right? A third one was the Green Revolution. So where Norman Borlaug, a Mexican scientist, I believe, and working with the cabinet secretary back then, smuggled in some of the varieties of wheat into India, and that were going to be far more resistant to drought and all that, and we sort of sorted out the problem of famine. So we now have done the same with digital technology, right? The last decade has been starting with Aadhaar. We have e-Aadhaar, we have e-sign, we have e-KYC, we have electronic payments, we have electronic toll, we have GST, which is a completely electronic tax collection system. So all of this has been enabled, and I would say that the government has embraced technology in a way like never before. And because of the pandemic, that has been sort of completely resolved, right? The digital technologies in every aspect of government. We have a lot more to do on cybersecurity. We need to safeguard these systems. It's a work in progress, but I would say that government has figured technology out to a certain extent, to a large extent. Last year and this year has been a focus on biotechnology, right, because of the pandemic. And India has again shown that, with our manufacturing capability, we can deliver vaccines at a cost to the rest of the world that is unheard of in the rest of the world, right? We are manufacturing for $1, $1.50 what the US is paying $20 to $30 for. And so I just think that this is the way progress keeps happening. Science is an essential part of it. The IITs are crucial, but so is the larger Indian engineering and scientific ecosystem. And I think open source is a big part of it. And I would urge every listener to participate in open source, in science, in technology in a big way, because this is the only way that we can solve the problems that face us. We have a very large population. Our problems are of a different magnitude. And if you are a youngster, think about a stint in government as part of your career. I think you will find it incredibly valuable personally and for the benefit of the country.
That was a wonderful answer, sir. So, in Rebooting India, a central theme is to reimagine the institutions of government. So, in that context, what are your views and in the newly introduced national education policy and the changes it envisions, such as the revamping of delivery methods of education and an introduction of technology-driven projects?
Yeah, that's I think you hit on a very important point there. So rebooting India is not just about taking some technology and putting a website on it. Rebooting India and the Aadhaar and the projects I talk about using technology in a completely transformative way, as opposed to simply sort of technology for the sake of itself. I like to sort of separate it from what used to be called e-governance projects or e-government projects, where sort of if I have a birth certificate that was being created by hand, I now create a website and now I print out the birth certificate, right? But you're still getting the paper birth certificate in your hand, right? That is not a true digital transformation, right? True digital transformation is your data is all in the cloud. It is, I have my DigiLocker. Every document that I care about is on it. It's available through APIs. It's electronically secure. I choose who I share my information with. I have my data and privacy protected, but I also simultaneously can use my data for my own benefit as well, right? So um, a lot of these projects help think about digital transformation in a fundamental way, right? We did not say, hey, take something and let's just stick a website on it, but let's think through the actual process and think about how do we re-engineer it. And a large part of this process re-engineering is re-engineering of the government itself. What is the role of government in service delivery? What is the role of government in general in society? And every time you have a technological shift, the role of government also changes, right? So, when we decided, to embark on atomic energy, I mean, government was not about doing research and building out these scientific institutions, but now that became a part of the government. And then it had all these amazing use cases that came out. Space is an exciting new frontier in business today. If we didn't get started with ISRO back when, we did, we would not have been there. We would not even be in the running today, right? And the same is true with digital technology, right? So, but once these transformations come, government itself needs to change. So, for example, government is always hard, right? It's hard to do everything in government because you don't have a single boss, right? Parliament can question you, the governor of the state can question you, prime minister can question you, every department will ask you a question, any secretary can call you, any MLA can call you, any MP. So if you're running a government department, it's not like a company where you answer to one boss, the CEO answers to the board answers to the shareholders. Everybody, press has a view, and you and I have a view. We go on social media and, we directly ask the prime minister, right? If the street lamp is not working now, we don't want to talk to the local corporator, for example, right? And so it's in this noisy environment that you operate in the government. And so you always think of, I want to do the smallest possible thing I can, leveraging the ecosystem. So in Aadhaar, for example, instead of using government enrollers, we use private sector enrollers. But through technology, we created a mechanism to monitor the rollout. We provided the software, everything was in the cloud. So government retailed the control. It set the pace of execution. It set the financial incentives. The government paid for all of this stuff so that the people did not have to, but the enrollment agencies, got made whole. So we created this entire financial and technological infrastructure that allowed basically a department of 300 people. That was what our UIDAI was at the peak when I was there. So 300 people running, enrolling a billion people in the country, right? I mean, as opposed to, think about other departments of government which have tens of thousands of people because they were designed in a pre-technology era, right? So we have been able to reimagine our institutions or the role of government, and with a very small footprint, execute such large and audacious projects. And you're going to see the same with the vaccination in the next, in this year and next year, and you're going to see the same with many other problems. So this is how, and it's not just about technology or digital technology, right? I think that this is the same in all forms of scientific technology. The other big one that's going to be upon us is electrification of our of all our various sectors, right? We need to wean ourselves from carbon dioxide generating things. And every car will get electrified, every rickshaw will get electrified, the power grid will be upgraded. We will have renewable energy, which is very bursty, as we know, and it will put a huge stress on our grid. We also what happened in Texas with a recent snowstorm there and lack of power, and it was, everyone was back to the, were as if they were living in caves for that duration, right? So we have all of these things that are going to be upon us, and it is only the government, by setting policy, by setting the right incentives and working with, the rest of the country, that can enable this change. And I think this is how, uh, the way we do things in India has changed now, and will change going forward. So this is my view on that.
Yes. Sir, could you tell us more about how you got fascinated with computers, coding, and logic as a child? And were most of the things you learned self-learned? And do you think there would be a difference if you had been taught those things as part of your curriculum at school?
That's a very good question. I'll share my personal journey, but I think, what works for one person doesn't work for everyone, right? So I was largely self-taught when it came to programming, because it was an additional subject in my school, actually, in our eighth standard. We had old IBM PCs. There was no network, there was no internet, there was nothing. And but my school had sort of this computer lab. It was reasonably new back then, and we had sort of we all were taught basic programming back then, and you had to put in a floppy and you wrote your program, and if you forgot to save it, it would be gone when you turned off the computer. And then you had to sort of keep it on your own floppy. And that's how I got started. And I was just fascinated that anything that I had learned, and back then I was learning the Newton's laws, for example, basic physics, basic science. And I would always be like, oh wait, I have this mathematical expression, can I write it in basic and see what the computer says? After all, glorified calculator, right? And so unwittingly, I kind of started on the path of scientific computing, unbeknownst to me at a very early age. And once I cleared my 10th standard, my father and mother bought me a computer at home, and I took it apart immediately, and I saw what's going on inside, and started writing even more programs. And that just became a hobby and a passion of mine, that any new science that I learned in college, I would just go and write a program for. So I got a much better intuition of gravity, of Newton's laws, about electricity, magnetism, about chemistry, about elements. I wrote programs for all of these things in basic, and it was such an easy environment that a kid with no real training could actually read up documentation and write all these things in an interactive way, with graphics, with visualization, in a very small system. You don't have such systems today, but it's one of the things that we are trying to build with Julia, that sort of to be able to rekindle that spark, right? To make it that easy, so that someone in middle school or high school can actually sort of get started. You don't have to be a university specialist to leverage the power of Julia. So that interactivity, the graphics, the plotting, all of that stuff. That's how I got started. One of the things, I'll share this story also. So, I studied very hard for the IIT joint entrance exam, and but I didn't make it to the IITs actually. I could, organic chemistry was something that always escaped me. So the fact that you're at IIT Chennai and talking to me right now is IIT Madras, is that you probably did figure out organic chemistry. But that combination of what the pace that the joint entrance exam set compared to the 12th standard state board, right? the level of education it set, the force, that it put on all of us as students was incredible for me. I think I credit the joint entrance exam with my interest and success with scientific computing, right? That's where the journey began, is fundamentally understanding science and math at a level that was far superior to someone who should have been at that age anywhere around the world, and combined with sort of my personal interest in programming, that's what got me going. So this is my personal journey, and that led to, I ran into a few mentors, Ajay Shah and Susan Thomas from the Indira Gandhi Institute. They're economists, IIT trained back then, and I learned a lot about programming, all kinds of new systems back then from them. And then, I enrolled in a PhD program. John Gilbert, Alan Edelman, learned all my numerical and scientific computing from them. So there was an element of self-teaching, and there was an element of having the right mentors who were able to sort of take me through the journey, and go forward. Again, I learned a lot of finance from, for example, Rajneesh Mehra was a very famous economist. So over time, whether you learn something in a classroom setting, whether you learn it online on Coursera, or many of the digital initiatives that we have in India now, or whether it is from a mentor, right? I mean, learning happens in many different ways, and but self learning cannot be replaced, right? At the end of the day, you have to learn. And I strongly believe in the power of computer science and of programming being essential for everyone. It should no longer be just a computer science discipline. Programming should be across disciplines, right? It has changed the world, as you know. It's like math, right? We don't say that only mathematicians will study math. Everyone studies math. So everyone needs to be a programmer. Everyone needs to learn computer science, in my opinion. And I think that's already happening. I mean, I'm not, I won't be surprised, but I think it needs to be a lot more. And there are lots of amazing examples of things that are going on. And I believe that's also maybe partially the goal of the upskill program, is to make that happen.
Yes. So on that note, computational thinking has become something of a buzzword nowadays. So what are your thoughts on computational thinking implementation in school? And as an enthusiast for programming, how do you think the current situation can be improved in that regard?
Yeah, so that's a very good point, right? So computational thinking is one of the phrases that, at least, I think many people must have come upon simultaneously, but it's a phrase that Alan Edelman coined for his class at MIT. And so if you go to computationalthinking.mit.edu, it has a beautiful set of lectures. I mean, they've gone really viral. There are, many of them have hundreds of thousands of views now. But and the class is actually on right now again. So if you're interested, you can follow it online at computationalthinking.mit.edu. And it basically refers to this idea of thinking about everything from a computational perspective, right? That, if you learn about an algorithm in class, just write the program, right? Don't think about it too much. Write the program and see it in operation, right? So here's a simple example, right? That if someone told you that, you can compute pi if you just have the area of a square and the area of a circle, right? So area of the square of size of length L, would be L square, and the area of the circle that is inside that square, touching all the sides of the square, would be, the radius would be L over 2. So you have, pi times L over 2 squared. So pi L squared over 4 would be the, so think about it as a unit square and a unit circle. The area of the square will be 1, and the area of the circle inside it will be pi over 4. So 3.14 over 4, little less than 1. So, what's the computational thinking version of this, right? I can say that, well, if I didn't know these formulae, what I could do is that I could have I could think about it as a game of throwing darts, right? So I put up a dart board with this circle, with this square, and then the circle which is inside it, and now I start throwing random darts at it. Some darts will land in the circle, some darts will land, outside the circle, but still inside the square. And then if I throw thousands of darts, I can count, I can take the ratio, and what you'll find out is that if the darts were randomly thrown, then you will sort of, the ratio will give you sort of an approximation to pi, which is a transcendental number. You cannot, it's got infinite digits in it, right? It's not a rational number. So, but how, this is one way to calculate pi, is that, you know, it shows up in this formula of the ratio of the area of a circle to a square. And if I think of it as a simulation, right, where I throw random darts and then take the ratio, then in a computational way, I have learned how to approximate pi. And now you can imagine that as you throw more darts, you get a more, you know, a better approximation to pi through this calculation. It turns out it's a terrible way to compute pi, and Ramanujan had many better ways to compute pi, and he did not need a computer. But all of us are not Ramanujan, so we need to have these computational tools. So, but this is something that computational thinking enables for all of us, right? That it actually gives us another tool, right? So think of, I like to think of these three things, right? So, you know, if I'm a scientist, I have theory, I have experiments, and then computation is the third part, right? So it ties the theory and experiments together, but I don't need to go into the lab to do an experiment. I can explore new theories by looking at data that were, you know, that's not an existing theory that we know of, right? For example. So computation, in my mind, is a true third pillar of science, along with theory and experiments. And this is why I feel like it has such a crucial role to play. That's why computational thinking is important, along with all the other forms of you know science and math education that we receive today. And today you can program even on your phone, right? You can program on this. I mean, I have a Julia sticker here, so you can actually access Julia right there. um, One of the things I think we should, for example, as we think of our curriculum, as we think about how students are taught, are introduced to things, I mean, I would say that, hey, since Julia has had such a great impact starting out from India, right? I mean, I was actually based out of India when I did it. There is a strong community of contributors and users. Lots of students joining Google Summer of Code, for example. Half of Julia Summer of Code students, Julia Google Summer of Code students, are actually from Indian universities. And I really think that in order to sort of solve all these challenging scientific problems that we talked about, that the government needs to solve, that we as a country need to solve, and having this robust scientific base in the country, we ought to teach people computational thinking from a very early age, as early as possible. Not everyone is cut out for it. Not everyone would appreciate it. But I think it needs to be introduced much earlier to a much wider audience than before. And if I had a magic wand, I would say everyone should just learn Julia starting either fifth grade, if not eighth grade, in my opinion. And the tools are all there. I mean, it's all free, it's all open source, the lectures are there, the videos are there, and you guys are doing a fantastic job training the trainers, as I like to think, right? And that if you train the next generation of teachers, they'll then go and teach these things to their students. So I do think that computational thinking should be an essential part of everyone's, or at least everyone who's going into the sciences as a study.
Thank you for that inspiring answer, sir. So, to conclude, what message would you like to impart to the students in the audience today regarding effectively utilizing technology in today's world and leading a wave of change in the way society functions?
So that's a very broad question, and it's a difficult one, actually. So I don't really have very good advice, because often advice tends to be tailored to a personal experience, and I shared my experience, so you can imagine what the advice would be. That I would suggest maybe work on open source, maybe join the government, right? So uh, hopefully my experiences that I shared help people at least put them into perspective and maybe add some information to their information set. But there's so many other things that you can be doing, right, in so many different domains. So my advice would be, believe in the power of science and technology. Do learn to program. You're going to need it irrespective of what you do. Do work in the government. It will open your eyes, and instead of complaining about how nothing works, you can actually make one small thing work, and it is going to be it's something that nobody might tell you. It is something that your family will definitely not tell you to do. They'll all want you to go to the private sector and get that coveted position. And it's not one or the other, right? you know uh, stay in the private sector, go to the government, come back. Some people graduate from IIT, join the IAS, and spend a life in government. Some people actually go back and forth, such as me, for example. Like I would love to be back working on some challenging aspect of government projects in India. Um, but do think about that in a serious way. Um, and then I think I don't have much more to share beyond sort of these things, right? But engage. I would say that open source is very valuable, especially if you're a student. LinkedIn is no longer your resume. It's GitHub that is your resume, especially if even if you're not a computer scientist, if you're not like a computer engineer, right? Let's say you're a mechanical engineer, you are learning how to program, right? I mean, everyone is a programmer, but every engineer is a programmer, and GitHub is your resume. So you will differentiate yourself from everyone else if you have contributed to open source projects. You get access to open source mentors in areas, you don't have to write a Python library, right, or software of that. You can write computational software and work with a mechanical engineer at MIT, for example, on an open source project, right, or on a scientific project, something that is close to your area, your discipline, but is in the area of open source software, right? Because you're probably already using tons of open source software yourself as you go through your courses. So it is not hard to imagine how that could be better, how that could be extended, so on and so forth. This is how the Julia community has grown, is people exactly contributing like that. And those GitHub contributions become, so when someone comes to me as a student who's like interested in an internship or a job, I'm much more interested in looking at their GitHub profile, if they have one. It doesn't, not having one does not mean you're not qualified for a job, but it is increasingly what people look at. And especially for companies like us at Julia Computing, which are in the open source domain, naturally we like to see what people's open source Julia contributions have been. It gives us a much stronger signal than any exam. In fact, we do not administer an exam to an incoming employee at all. I don't believe in asking about that binary tree, red, black, whatever that thing is. I'm pretty sure I could never figure it out in an interview myself. Um, the red, black tree algorithm or whatever it is that Google or Amazon asks you nowadays. So, but we strongly believe in hands-on coding, in seeing what projects someone has actually done, having those be public, right, as opposed to private. I think in and putting things out there, I think is what I would advise people to do. But take all the advice with not just a pinch but a bucket full of salt, because it's always from the perspective of the advice giver.
On that note, thank you, sir, for being a part of the Spotlight Lecture series and for some really thought-provoking answers. So, for the audience, please find the link to the feedback and attendance form in the live chat. Viewers who attend 4 or more lectures will get e-certificates as part of Shastra. We thank the audience for your patience and hope you had a wonderful time. Thank you once again.
Thank you.